Let's look at a couple more examples. So in the last video we looked at some of these powers of sine or cosine. And we did an odd power and we did an even power. All of those just had sine or cosine though, and we should look at ones that have both sine and cosine. The advice is basically the same. It says if they're both even, then use one of these half angle formulas right here. And if you've got at least one that's odd, then we'll split it off and use Pythagorean. So still kind of the basic same ideas. So let's look at one where they're both even. We've got sine squared times cosine squared. And the recommendation there is to use each of these half angle identities. So we will just rewrite this integral. Sine squared is the same thing as 1 minus cosine of 2x over 2. And cosine squared is the same thing as 1 plus cosine 2x over 2 dx. Some of my trig students remember these as sinus minus and cosinus no minus, if that helps. If it doesn't, then you don't have to memorize these formulas, obviously, this quarter. But okay, let's see if we can simplify this a little bit. Multiplying the bottoms of the fractions together gives you 1/4, which I'm going to pull out front. And multiplying the tops together is a FOIL, first outer, inner, last. It becomes 1. It becomes, you get a minus cosine 2x, and you get a plus cosine 2x, so those cancel. And then you get a minus cosine squared 2x. The 1 will be easy to integrate. The cosine squared, we're going to use trig identity, half angle identity again. So I'm not going to do any integration. I'm just going to rewrite this one more time. 1 minus, and then cosine squared, you get the plus and double the angle. So this becomes 1 plus cosine 4x. And that's all over 2 dx. And maybe here, just to squeeze this in one more time, we'll turn that into 1 minus 1/2 minus 1/2 cosine 4x dx. Okay, and I'm not actually going to do the integration. All three of these pieces are pretty easy to integrate. The cosine of 4x will take a little U substitution. But okay, let's go ahead and look at this one that's got at least one. At least one says split off the odd power and then use Pythagorean identity. So maybe you can't quite see exactly how that's going to work yet, but let's take it on faith. So let's do cosine of 5x, split off one of those. So this will become cosine to the 4th of x times sine squared of x, and then I'm going to stick one more cosine x here on the end. This cosine of x here on the end is making me think about U substitution. Really, what's mostly making me think about is the du. Looks like it'd be great for du to be cosine x, which means it'd be great for u to be sine x. That means I'm happy with the signs there. The cosines, though, I'd like to have that written as more sine stuff, and that's not too hard to do. So cosine to the 4th is cosine squared squared. And then the cosine squared is the same thing as 1 minus sine squared up here. So Okay, so now we are actually ready to do this u substitution right here. So let me switch back to purple and say this is going to be the integral 1 minus u squared squared times another u squared times du. Granted, these u's need to get multiplied out, right? And I'm not going to finish this problem either, but this would be 1 minus 2 u squared plus u to the fourth. And we still have a u squared we need to distribute 3 places. Oops, sorry, I wrote on top of that too. But anyway, it's going to be a polynomial in u, and we can integrate it in terms of u, and then ultimately replace all those u's with signs of x's. Since these are both indefinite integrals with no limits of integration, you will not forget to put a plus c on the end of both of those when you're done. Okay, there's an example or two in the homework with tangent and secant instead of sine and cosine. And I'd just like to remind you there's a similar trig identity about tangent and secant instead of cosine and sine. It's in the book, and I'm not going to do an example of that, but I just wanted to make you aware of that as a possibility. All right, go forth and integrate some trig.